Hey guys, Mr. Backerberg here. In this video, we're going to look at solving inequalities using addition and subtraction. So an inequality is a mathematical sentence that is formed by placing one of these symbols between two different expressions. Now let's talk about what each of those symbols means. So first we have this x with a symbol between it and a 7. That symbol pointing to the left, where the arrow is pointing left, that's the symbol for less than. So if we were to read this out, we would say x is less than 7. Now if we look down below, this one is very similar, but now we're putting that line underneath our less than symbol. And that line adds an extra piece to the inequality. And that means that x could also equal 3. So we would read this as x is less than or equal to 3. Now we've got some other symbols. This one where the arrow is pointing to the right, that's our greater than symbol. So we would read this as x is greater than -4. And this other one, similar to what we saw before, as soon as we put that line underneath it, we're adding that extra equal to piece. So we would read this as x is greater than or equal to 12. Now, one thing that we're going to be doing as we look at these inequalities is graphing them out on a number line. And depending on what your inequality symbol looks like, that kind of dictates something that we do as we're graphing out these inequalities. So if we see just a less than or a greater than symbol, that means that the end value that we're talking about in the inequality is not included in the solution set. So as we're graphing that out, we want to graph these ones out using an open circle on our number line. But as soon as we put that equals to line underneath our inequality, that means that we do want to include that end value for the inequality, and we would graph that out using a filled in circle on our number line. So if we were looking at the inequality, x is less than 3, and we wanted to graph that out on a number line, the first thing I'm going to do is put some numbers on my number line. So I always like to put the number that we're dealing with right in the middle, and then as we go to the left, the numbers get smaller, so that would be 2 and then 1, and as we go to the right, the numbers get bigger, so that would be 4 and 5 on this number line. Now we want to talk about the numbers that are less than 3. So thinking about what we just talked about as far as graphing out a dot on our number line, this inequality does not have the equals to line underneath it, meaning that we don't want to include the 3. So we show that by putting an open circle around the 3. Now what we want to do is figure out all of the numbers, because x just stands for some unknown number. We want to figure out all of the numbers that are less than 3. So if we look at our number line, being less than means that it's smaller than 3, and as we work our way to the left-hand side, that's where those numbers get smaller and smaller. So what we're going to do with this is we're going to do some shading, and we're going to shade those numbers that are to the left of that 3, since we're looking at things that are less than 3. Now in this next example here, we've got x values that are greater than or equal to -1. Again, I like to put the number that we're dealing with right in the middle on my number line. Now as I go left, the numbers get smaller. Since we're dealing with a negative number, they actually get to be bigger negative numbers as we work our way to the left. So we would have -2 and -3. Now as we work our way to the right from -1, we would have 0 and 1. Now looking at this inequality, it does have the equals to line underneath it. So at -1, I'm going to graph out a filled in dot to show that we do want to include that end value of -1. Now if we're talking about the x values that are bigger, greater than -1, we're going to be talking about all the numbers on the right-hand side of that number line. So we're going to shade over to the right-hand side, and we'll put our arrow on the end. And that arrow means that this line would extend forever and ever. As you keep going further and further to the right, those numbers keep getting bigger and bigger, so they are still larger than -1. Now we can also work this in the opposite direction. We can be looking at a graph, and we can write out an inequality based on the graph that we see. So here on our number line, we've got an open circle at 9, and our line is pointing to the left, or we're shading to the left of 9, where those numbers are smaller than 9. So because we're looking at numbers that are smaller than 9, what we're going to say is that this inequality is all of the x values that are less than 9. And we don't want to put the equals to line underneath it because we are dealing with an open circle. So we don't want to actually equal the 9. We only want the things that are less than 9. Now, if we look at this one, we've got a filled-in circle, and it looks like it's about halfway between -2 and -3. And then our line is pointing to the right, or we've shaded to the right. So as we're looking at this, we're going to have x values. Now, because we're pointing to the right, this is going to be greater than or equal, because we do have that filled-in dot. And like I said, we're about halfway between -2 and -3, so I'm going to call it -2.5. That would be the halfway point between those. So we're looking at all of the x values, all of the numbers that are greater than or equal to -5, as we've got that line pointing out to the right. Now, as we take a look at this example, we're asked to solve this inequality and then draw a graph. All of the inequalities that we've looked at up to this point have always had x all by itself on the left-hand side. And that's what we're going to try to do with this. Right now we've got x minus 5 is greater than -4. We want to solve to try to get our x alone. And this is going to be just like when we solved an equation. We want to think about doing those opposite operations. So in here where we've got x and we're subtracting 5, well, the opposite of subtracting 5 is adding 5. So we need to add 5 on both sides of this inequality to help us cancel out that -5. So then if we do that, our inequality would say x is greater. Now if we take -4 plus 5, that's going to give me 1. So we end up with the inequality x is greater than 1. Like I said before, I always like to put the number that I'm dealing with in the middle on my number line. If we go to the left, we want the numbers to get smaller, so I would go 0 and -1. And then as we go to the right, we want the numbers to get bigger, so 2 and 3. Now going back to our inequality, we want x values that are greater than 1. So at 1, I'm going to put an open circle because we don't have the equals to line. We want all of the numbers that are bigger than 1. So we're going to draw our line, or we're going to draw our shading going out to the right-hand side. Now, as we take a look at this one, we've got w minus 9 is less than or equal to 3. So again, we want to think about doing opposite operations to try to get our variable alone. So right now I see w minus 9. In order to get rid of minus 9, what we're going to have to do is add 9 on both sides of our inequality. So on the left-hand side, the minus 9 and the plus 9 cancel each other out. So we get w is less than or equal to 12. So I'm going to go over to my number line. I always like to put the number that I'm dealing with directly in the middle. To the left, the numbers get smaller, and to the right, the numbers get bigger. So here's my number line. I want all of the w values that are less than or equal to 12. So at 12, I'm going to put a closed or filled in circle because we do have that equals to line underneath our inequality. Then we want all of the numbers that are less than 12. So on our number line, less than means we're on the left-hand side. So we're going to shade, or we're going to draw our line heading out to the left. Now, as we take a look at this example, we've got p plus 9.5 is less than 9. So again, we're trying to solve to get our variable all by itself. Right now, I see that we're adding 9.5. So if we want to do the opposite to get p alone, we're going to have to subtract 9.5 on both sides of our inequality. So on the left-hand side, the plus 9.5 and the minus 9.5 cancel each other out. So we get p is less than. Now when I do 5 minus 9.5, we end up with -4.5. Now I said before that I always like to put the number in the middle on my number line, but that's going to be hard to do with this decimal value. So what I'm going to do is kind of sandwich the numbers that are around -4.5. So I'm going to put -5 in the middle, and then on the right-hand side, I'm going to put -4 because the numbers get bigger to the right, and that -4.5 would be halfway in between those. Now, as I work to the left, the numbers need to get smaller, so I'm going to do -6 and -7. Going to the right, we want bigger numbers, so we already have the -4. I'm also going to put -3 over there. We want p-values that are less than negative 4.5. So halfway between negative 4 and negative 5, I'm going to put an open circle because we don't have the equals to line, so we're not including that end value. And we want the things that are less than negative 4.5. So on the left-hand side is where we're going to do our shading or drawing our arrow, because that's where the numbers get smaller as we're looking at this number line. Now in our next example here, we've got 9 is greater than or equal to x plus 7. Again, we're going to solve and try to get x alone. So right now I see that plus 7. So what I'm going to do is subtract 7 on both sides of my inequality. So then I get 2 is greater than or equal to x. Now this looks a little bit different than all of the inequalities that we've dealt with up to this point. Up until now, all of the inequalities have had the variable on the left-hand side. So we're actually going to take this and rearrange it so that we do get our variable on the left. When we're dealing with inequalities, we do always want to have our variable on the left-hand side. So what I'm going to do is I'm going to switch places with the x and the 2. So I'm going to put the x on the left-hand side and the 2 on the right-hand side. But when I do that, because I flip-flopped the order on these things, I also have to take that inequality symbol that's in the middle and flip it around as well. So originally it was a greater than or equal to, but if we flip it around so it's pointing the opposite direction, then it's going to be a less than or equal to. So now I'm going to take this inequality and head over to my number line to graph this out. So I always like to put that number that I'm dealing with in the middle. So I'm going to put 2 in the middle. The numbers get smaller to the left, so I'm going to go 1 and then 0. The numbers get bigger to the right, so I'm going to go 3 and then 4. We want x values that are less than or equal to 2. So at 2, I'm going to put a filled in circle there, or a filled in dot, because we are including the 2 because of that equals to line underneath our inequality. Now we want the numbers that are less than 2. So if we look at our number line, the numbers that are less than 2 are happening on the left-hand side. So I'm going to draw my arrow or draw my shading pointing to the left. Now we're going to wrap things up with a little bit of a word problem here. So you are checking bags at an airport. You're going on a trip somewhere. Your bags can weigh no more than 50 pounds. The bag you've got right now weighs 16.8 pounds. We want to try to write out an inequality and then solve it to help us figure out what additional weight we could add to the bag if necessary. So the total weight of the bags can be no more than 50 pounds. You cannot go over 50 pounds. So the weight of the bags, it's going to have to be less than or equal to 50. We're not allowed to go above 50. We want it to be smaller than 50, but being exactly 50 pounds is okay. So right now, we've got 16.8 pounds in there, and we're thinking about adding in some additional weight. So I'm going to write that as 16.8 plus W, and I'm going to call it W because we're talking about adding weight. Now what we want to do is solve to figure out how much more we could add to this bag and not go over that 50-pound limit. So right now, we're looking at solving to get W alone. I see that positive 16.8 on the left-hand side, thinking that we want to take that and move that over to the other side. Because it's positive, what we're going to do is subtract 16.8 on both sides of this inequality to help us cancel that out. So we would be left with W is less than or equal. Now if we take 50 minus 16.8, we're going to get 33.2. So that means that we can add up to 33.2 more pounds without going over that 50-pound limit. So I'm going to write that out. You could add up to 33.2 more pounds without going over 50. That's going to be it for this video. Thanks for watching.